Okay, here we go. So today we're going to be digging into, again, some more of these foundational things. And as you may recall, we talked previously, before we started our 3D unit, we talked about point, line, plane, the building blocks of geometry. Really, that lesson, that 1.1 lesson, really applies more to what we're going to start today and moving forward. That language is going to be really important. But I put it where I do before the 3D unit, because then I can say things about points and lines and planes, and I can use some of that language. But really, the notations that we talked about are really going to come into play starting today and moving forward. Okay, now, one of the things that we did talk about was the difference between lines, rays, and segments, right? So a line extends in both directions infinitely. A ray has a clear endpoint and extends in one direction infinitely. And our segments have clear ending and beginning points, right? And so we're going to be talking about segments today because we want to measure them. And we can't measure an infinite line because it's infinite, right? So we have to have a clear beginning and ending point. Now, we're going to put some language to this that is important that you understand, and we're going to put some writing to this that's important that you can make sure that you're clear on the difference of. Okay, so, hi.
Hi. And then who has Silas as their senior? This is for them.
I don't know who that is. Who has Silas?
Yeah.
Okay. Okay. All right, so we're going to jump in here right away. We're going to talk about the distance between 2 points, right, can be written like this. So in language, if we were saying it in English language, we would write it like this. The length of segment AB, right? So if we were talking about the length of this given segment right here, it would be 1, 2, 3, 4 units long, right? But we can write that phrase, that whole statement, the length of segment AB, like this. What did I do different from here to here? Did not put a line on top. Okay, and what we're going to talk about is this notation from here to here is the difference between what we call number language and figure language. Okay, and it's an important differential for you to make in this class, all right, because you have to write correctly, right? So this would be like capitalizing, proper names in sentences in English class, something like that. There's a way of writing correctly when we talk about figure language and number language, but without the bar on there, this reads the length of segment AB. Now, because this is number language, we can use an equal sign, and so then we can say the length of segment AB is 4 units long. Okay? We would not say this right here is equal to 4 units long. That's improper geometric notation because this is figure language, this is number language, and we need to be able to replace this value right here or this statement with a number. Okay? Now, when we have segments that are of the same length. So you can see here we have these 2 segments that are of the same length, and we've used this word a little bit already, this word congruent here, right? We could make this statement right here. If the length of segment AB is equal to the length of segment CD, you see how I said that when I wrote that? I didn't say figure AB is the same as figure CD. I said the length of, right? Then we would say that the segments are congruent, okay? And when we say congruent, what we mean is that they have equal measure in all aspects. And we have a special symbol we use for that. It is an equal sign that has a little squiggle on the top of it like that. This is our sign for congruent. And this is how we relate figures to each other. So I could say figure AB, or segment AB, is congruent to figure CD. Do you see the difference between those 2 statements? This one is figure language. I'm referring to the actual shapes themselves. In this case, it just happens to be line segments. And this is referring to the length between these 2 points and these 2 points here. Okay, so let's clarify this just a little bit. So put a star here, and then let's swoop a little arrow down here to this blank space, and we're going to first start off writing out figure language. When we say figure language, which would look like this, segment AB is congruent to segment CD. What we mean is this. So segment AB and segment CD are exactly the same. They're exactly the same. And I'm going to use this terminology as we go along. I'm going to refer to congruent things as being like identical twins. Okay? With identical twins, everything down to their DNA is exactly the same. Okay? Everything down to their DNA is exactly the same. Now, number language. Which I gave you above, looks like this. The length of segment AB is equal to the length of segment CD. Let's write that down. Swoop a little arrow down here like this. What you need to know is when I write it like this AB or this CD is kind of like a variable. In that it can be replaced with a number. So while this notation right here refers to an actual figure or shape or item, this right here is a numerical value. This is like, just like having an X or a Y, we can replace that with a number. This cannot be replaced with a number. Now, it may seem kind of counterintuitive at the moment because you're like, well, those kind of seem like exactly the same thing. However, as we get more complicated shapes, like let's take a triangle, for example. We're going to talk a lot about triangles in this class, okay? And triangles, there are multiple parts to a triangle. There's angles, there's different sides, right? And so when we say a triangle is congruent to another triangle, we're saying in one statement, every single part of this triangle here is exactly the same as every single part over here. And because of the way we write the statement, we can match up all of the parts that go with each other. And we can say that in one statement. But we can't say one triangle is equal to another triangle. We could say one side of a triangle has the same length as another side of the triangle, or we could say one angle measure has the same degree measure as another angle measure, but we can't say it all in one statement. Okay, and so as those figures become more complicated, this becomes a more powerful tool. Now, depending on the geometry class that you're in, okay, some are more stickler about this, some don't even care about it, okay? I tend to ride a little bit in the 60% side, 65% leaning towards stickler. It's important you know the difference, all right? Like if you go to do an IXL proof, okay, you actually have to change from figure language to number language before you can do your math problem, and then go back to figure language before you can finish your proof. And if you don't make those changes, you're not going to get that question right on IXL, okay? I'm not going to be that much of a stickler about it, but I do need you to know the difference between referring to figures versus referring to numbers, okay? So make sure that you're clear on that, all right? Everybody good so far? Figure language, number language, okay. All right, now, you're going to hear me use this a lot this year. I'm going to talk about your geometry tool belt. And your job is to pull the right tool out of your tool belt at the right time and use that tool accordingly to set a problem. So we're going to start with our first tool here, which is our segment addition postulate. So I will expect you to be able to name this tool and use it accordingly. So this is a new tool. All right, and so this is what the segment addition postulate reads. This is written in geometry language. It says, if A, B, and C are collinear, hit the brakes right there. What do we mean when we say A, B, and C? Capital A, capital B, capital C. What are we talking about? Just give me it. Yeah, points, right? Locations somewhere in space, right? But not anywhere in space. Those points are collinear. What do we mean by collinear? They sit on the same straight pathway, right? So this would be a picture of points A, B, and C, all right? So A, B, and C are collinear, and B is in between A and C. Does that mean that B is in the middle of A and C? I heard some yes, I heard some no. Is it in the middle of A and C? Is there a difference between in between and in the middle? There actually is a difference, yeah, right? And so we're going to talk about that, and so you have to be clear on that language. So B is somewhere in between. Could it be in the middle and be in between? Yes, absolutely. But it could also not be in the middle and in between, okay? So you've got to be clear on that, all right? Okay, so what we're saying here is this is our segment addition postulate. If B sits in between A and C and they're all collinear, then the length of AB plus the length of BC is equal to the length of AC. Does that make sense? Think about it. It's pretty logical. AB, BC. How many pens long is AB? Okay. How many pens long is BC? 2. Okay. The length of AB, A to B, B to C. How long is A to C? 3 pens long, right? Segment addition postulate. When we take two parts of a pathway and we join them together, that is our segment addition postulate. Okay, all right. Again, like I said, remember, the math is not that complicated. It's knowing what the tool does and when to use the right tool. I just showed you how a drill works. Okay? You're like, oh, okay, I got that. That's easy. Sure. But then, when you have a multiple set of problems, will you choose the right tool for that job? That's what you have to do. Okay, now, I'm going to kind of farkify this just a little bit for you.
I like that word.
Thank you. Thank you. I like to think of this as part plus part equals whole. So visually it would look like that. Or over here you could think of it as part plus part equals whole. Now this is part plus part equals whole for segments. We're going to have part plus part equals whole for other things as well. So just keeping that in mind, this idea of two pieces put together make a whole. All right, we good so far? Yes, ma'am.
So why, for like this example, why is there no like line of thought? Why is it not?
For this right here? Okay, perfect question. Thank you for asking that. Okay, so we're doing addition, right? We don't add figures together, we add numbers together. So this has to be written in number language in order for us to do mathematical operations. Thank you, Lauren. You've given us the exact reason why we have to write it that way. It is not okay for you to do this. That's wrong. Okay? That's wrong because we don't add figures together. We do math with numbers. And so that's the difference between figure language and number language. That's the difference between the 100 and the 96 and the 92. And, keep that in mind. Okay? All right. So here we go. We're good so far?
Yeah.
Okay. All right. So we're going to use this picture right here. We've got 3 collinear points. Okay, we're going to use this picture right here to answer questions 1 and 2. So if PQ, see the length of PQ is 9 units long. The length of QR is 28 units long. We're going to find the length of PR, but we're going to do it like this. I want you to define PR as the variable X. And first, right here on your paper, I want you to write me a segment addition postulate math problem that's going to help me find the length of PR, and we're going to use an X for our unknown in that math problem. Go ahead. You write the math problem right now. Let's see what you can do. I put that right there. That's what I asked you to do. I didn't ask you to find PR just yet. I asked you to write me a math problem using segment addition postulate. Okay? All right? Okay, good. Then we can solve, and we can say X is equal to 37 units, like that. Setting up the problem and then solving it. Very simple example. Okay, I want you to write me a segment addition problem for if the length of QR is 17 and the length of PR is 21 find PQ. Go ahead. Write me a math problem and figure it out. I'm sorry. Yeah, oh, yeah. Thank you. Yeah. Let's do PQ as X. Thank you. Yes. We'll just make it easy. Put that. Yes? Did anybody put a subtraction problem there? Okay, that is not right. Because this is not the segment subtraction property. This is the segment addition property. Okay? Just like Pythagorean theorem is not written c squared minus b squared equals a squared. It's written a squared plus b squared equals c squared. The subtraction part comes in the solving. Same thing here. I will be grading you on, did you set up your problem according to the right tool, and did you name that tool properly? That's one of the things I will be grading you on. And then you have to be able to do this math problem, which is subtract 17 from both sides, and you get x is equal to 4. That's the easy part. That's the algebra part. That's not the part I'm really all that concerned about. The part I'm concerned about is do you know which tool to use, and can you set up the problems accordingly? Does that make sense? That's what I'm looking for. All right. If the length of EG is 71 units long and the length of EF is 8 minus 17 units long and FG is 5 minus 3 units long, over here in this space, write me a math problem using segment addition postulate that's going to help us find the value of X. Let's just start with the setup. Make sure you get it right. Go ahead. Give it a try. This right here. Now, I didn't tell you to write this part just yet, but now you need to start writing this part. Because on your assessment, you're going to have to identify for me what tool did you use to set up your problem accordingly. And this must match this. If you name the right tool and set your problem up wrong, or name the wrong tool and set your problem up right, well, that's not 100% correct, is it? So you need to make sure to name the tool you're using and set your problem up correctly. And then this is the easy part, right? This is the part that's simple. All right, finish it up and find your answer. Go ahead. Should have come up with x equals 7. Okay, now let's talk about work. We are now at the point where I don't want to see all of the stuff that goes on in between the lines here, okay? You should be able to combine like terms. You should be able to, add 20 to both sides, and I don't need to see all of that. I don't need to see that you're dividing by 13, and I absolutely do not want to see, long division on the side of your paper. That's what you have a calculator for. That's why I let you use a calculator. Okay, so keep your work neat and clean. You don't need any extra stuff in there. Just move from one equivalent equation to the next. Just that simple. Okay? Reading's happy about that. All right, good. Okay, let's do 4. Go ahead. Give it a shot. Let's see what you can do. All the way through. I'll give you the setup in just a second, and then I'll give you the answer. But you go ahead and get your problem set up, identify your tool, write it correctly, and then let's see how you do. The answer is 29 because it's asking you to find the length of TU. Okay, important geometry lesson. Make sure you answer the question that's being asked, right? Okay, so in this case, you are asked to find, and you need to be able to read that, the length of segment TU, right? And in order to do that, you need to know x equals, which is 3. You're right about that. But then you have to take that 3, plug it back into this expression to find the length of TU. Now, that's also a great way on test day to make sure you got your questions right? Like, let's say you come up with x equals 3, you find TU, you plug it in, you're like, all right, the answer is 29, 29 plus 5 is 34, and then you go back and you plug in that same number in here, like that. You get 42 minus 8, and you get 34. Now you know that your segment addition postulate worked. Lauren. Because it's talking about the length of, and it's number language, see, because I'm using an equal sign there. So because there's no line here, it's asking you to replace that with a number. Okay? All right, good? Okay. 5 and 6 are yours to do from the get-go. Let's see if you can get them both right all the way through. 5 and 6. 1, 2, 3, ready, go. 5 and 6. 1, 2, 3, ready, go, all the way through.
This is a lot.
Finishing up, don't look up. If you're done, take a look, see how you did. You should have come up with this right here. All right, again, right? Pay attention to what you're being asked. The only thing circled on your paper should be the length of JL, and the only thing circled or boxed should be X equals. Answer the question that's being asked. Everybody good? Okay. Let's talk about number 7. Okay? So we're not going to do number 7 right now, but just to kind of talk you through it, right? So again, you can see that we have 3 collinear points. We've got lengths of different line segments, all given in algebraic expressions. So you're going to have to put those together in some way, shape, or form, and then you're being asked to find multiple things here, right? Not only what is the value of the secret number that is the same in each expression, right? Because when we have a variable in one math problem, it's the same. But then how can you use that to find these 3 lengths as well? Okay? That shouldn't be too complicated, right? Everybody good with that one?
Yes.
Okay, we're going to leave that one for now. All right. New tool. Right up here, I want you to write definition of and I want you to box that in like that.
Whoa.
Okay? So the definition of midpoint, or of a midpoint. All right, let's talk about that. So this is going to be a huge concept for us. The midpoint of a segment is a point that divides that segment into 2 congruent parts. Okay? Divides a segment into 2 congruent parts. Now, we can see that B is the midpoint of segment AC, and we can determine that from these markings right here. I want you to circle them and drop a couple little arrows down like this. These are called congruence marks. We've seen them. They've shown up in our 3D unit a little bit, but we're going to kind of define them out and make sure we're really clear on them. When we have these straight pathways and we put these little hash marks through them, what we are saying, and we put those hash marks in between the 2 endpoints of a line segment, what we're saying is that identical marks indicate equal measure. Identical marks indicate equal measure. So you can see in between the endpoints of segment AB, kind of in the middle, there's a single hash mark. And in between the endpoints of BC, there's a single hash mark. And so whatever that measure is from A to B, what we know is it's the same from B to C because of those little hash marks that are on there. And if that's true, from A to B is the same as B to C, then that means that B is in the dead middle of AC, and therefore it's it's a midpoint. Okay? Now, a line, a ray, or a segment that intersects another segment at its midpoint is said to bisect that segment, and it's called the segment bisector. And I want to be clear that when we bisect something, that means that we break it into 2 congruent parts.
I can't draw an arrow.
Okay, here, I'm going to give you a little notation to jot in up here. You ready? You watching? Make sure you're watching so you know where I write. Is K the midpoint of SY? How do you know? How do you know? How could you prove that? How do you know that? How do you know that? No. That's not a good enough answer. You can't say because look at it. That's not. That will not get you points. Who can give me a more specific reason than just look at it? Okay, hang on. Go ahead, Andrew. The congruence marks are not identical. That's what you want to say. Okay? Because there are different congruence marks, clearly then the distance from S to K and K to Y are not the same. Now, is K in between S and Y? Yes. Is K the middle of S and Y? Is B the middle of A and C? Okay, and you would need to be able to give a geometric answer to why those are different. Okay? And that's where those congruence marks come into play. Okay, now, so in the diagram to the left, we can say this. Why don't you write in, what do you think goes here? Is the midpoint of and line Girls, do you need to step outside to get it together? Are you sure?
Sure.
Okay. I'll give you this part right here. Is a segment bisector. Okay? Why don't you try filling in these blanks here? Let's see what you can come up with. How well do you speak geometry and write it? Go ahead, give it a try. Do you put that's?
Yep.
Okay, capital letter B has to be a capital letter because we're talking about point B. Is the midpoint of what? We would write that segment AC. So we would have to say, what did you say? Is what R?
It's cut off.
Oh, this right here? No, that's a B. Where are you saying R?
It's because the bottom is cut off.
Oh, no, it's a B. Yeah, this is a B. Of segment AC, not the length of, right? So we would write the bar over the top of that one. And then, did you name the line correctly?
Yes.
Yes?
Yep.
You can't say BL, you can't say line B, because you need 2 points to name a line. So we'd have to go to that old school, right? And that's the segment bisector again of segment AC. Okay, all right. Yes, ma'am.
So is a segment or like a midpoint, is it always going to be like the segment, like the line on top?
Well, it depends if we're talking about length or if we're talking about the part of the figure. So in this case, right, we're saying, what is B the midpoint of? Well, it's the midpoint of segment AC, right? We wouldn't say it's the midpoint of 17, right? That statement doesn't make sense, right? So we wouldn't replace that with a number. We're talking about a figure, and that's why we would use figure language here.
So midpoint is only for segment.
Well, no, midpoint is to understand that this is the dead middle of a segment, okay? And the segment bisector is what cuts through the line at the middle, okay? All right? Now, if we talk about the length of AB and BC, then we can replace those with numbers. That's when we wouldn't use the notation mark over the top, okay? All right. Let's see if you can do number 8. Over here, I want you to set up a math problem and name your tool accordingly. That will help you figure out the value of X if you know that Q is the midpoint of PR.
Okay.
See what you can do. Go ahead.
Are you really talking to this side right now? You didn't think what it was.
Are you ready? Here's your setup right here. Did you set that up correctly? Now notice this tool has you set up the problem differently than the last tool, right? You're not adding anything here. It's not like you're saying PQ plus QR. Here we're saying PQ is the same thing as QR. So this tool requires us to set up the problem a little bit differently. Now this is fairly easy. We only have 2 tools in our tool belt. By the time we get to December, we'll have about 20.
What?
And so you'll have to decide which tool to use accordingly. Okay? So it's going to get more complicated as we get more tools. And you're going to have to use the right tool. And sometimes the problem setup may look the same for one tool and another, but you still got to name the right tool to use. Okay, and then after that, right, then all we have to do is solve that out, and we come up with x equals 6. Yeah? All right, now I want to show you something else. Watch this. I'm going to give you this problem written a little bit differently, so I want you to write it with me here. So another way that I could give you this problem, I'm going to put a little point out here to the best of your ability, because I know you don't have all your straight edge stuff with you right now. Just draw yourself a little line, and then put another point out here, and then a point in the middle, and we'll call this P and Q and R. And we're going to go like this. Now check it out. This right here is enough for me to give you if I didn't tell you any of this and I just said, find the value of x. That's enough information for you to be able to set up this problem right here. Why? Because of these congruence marks, you know that the distance from P to Q and Q to R have to be the same. You could set them equal to each other. Likewise, if I gave you this right here, you could also say, well, Q is the midpoint of PR. How do you know that? Because the distance from P to Q and Q to R is the same because of the congruence marks. Great question. Okay, did you hear that question? That's an important one. Why did I put 2 congruence marks instead of 1? Because I felt like it. I could use 7 congruence marks if I wanted to. It's kind of a pain in the butt to write 7 of them, you know. But what we will see on triangles, like what's the kind of triangle that has 3 non-congruent sides, or 3 sides that are different lengths? Anybody remember? What's that? Scalene, yeah? Right, okay, scalene, right? Now, if we draw a scalene triangle here, I'll just draw one over here, right? So let's say I have a scalene triangle like this, and I want to tell you that this is a scalene triangle. Well, now I'll do that in the picture by going like this. See? Does that make sense? Right? So now all 3 sides aren't the same, right? So then when I give you this triangle here and I go like this, that's an isosceles triangle, right? Or if I give you this triangle here and I go like this, that's the equal value. Right? Okay? And so that's how we can communicate in diagrams, and that's another aspect to our geometry class, okay? All right, good. Nice job. Okay. Let's do 9. Let's do 9, top to bottom, identify your tool, set your problem up correctly. Let's see how you do. Ready to go. 9. Here we go. Should have come up with 17. How many people got that right? Let me see. All right. That's what I like to see. All right. Good, 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 good. So we have 2 tools now. We have segment addition postulate and we have definition of a midpoint. They require you to set the problems up in 2 different ways. Good? Okay. 11. So G is the midpoint of segment FH. We also know that segment FH is 6y minus 2. But FG is 4x plus 3 and GH is 7x minus 12. Find y.
So I see like the end of the problem that was
It's asking a lot of me.
Oh.
Okay. Go ahead. Bounce an idea off each other. Help each other out. Talk it around. come up with this right here.
Explain it. Explain it.
Well, before I explain it, why don't you study it? See if you can figure it out. It's easier. That's learning. Learning is when you look at it and figure out what you did wrong. I mean, I can tell you all day long, but and I will. But no, but I want to point something out because this is a really good observation that gets brought up pretty much every time we do this problem, which is this right here. Is that a legit setup for a problem? That's not segment addition postulate? Part plus part equals whole?
It is, but that's like...
Yeah, see, that's the problem is you end up with X's and Y's in the same problem and you can't solve, right? Okay, but that is still an example of segment addition postulate there. So this is what I'm talking about. This is where I say that the class gets more challenging is it's not in this part right here. That was algebra 1. There's algebra 1 in here because this is algebraic geometry. That's not the part that's challenging. It's using the right tool. And it's knowing that when you put this up and then all of a sudden you go, hey, you know what? I got 2 variables. I can't solve for one of them because I need a systems of equations to do that. Then you go, hey, maybe I took the wrong tool out of my belt. Let me try something else. That's the idea. Okay? All right. Now, did you get it, Pedro? Or you want me to explain it further? Okay, cool. Right on. There we go.